Okay, let's continue. We are still in requirement number 3. What if the quantity of side windows that can be purchased is limited to 15,000 units from Jones and 45,000 units from Claro? There is no limit from either source for windshields based on cost. What purchasing mix should be chosen? What problem does this create? What else might you suggest if you were the manager of Ventana? So actually, the purchase of the side windows is fixed with a limit that Ventana can buy only 15,000 from Jones and 30,000 from Claro. Okay, okay. Though it can buy 45,000 from Claro. Pero ang iyaya nga stated nga purchase is only 30,000. Now, with regards to the purchase of window shield, there's a limit that there's no limit. However, Bintana now can decide where to purchase kay wala man limit. And of course, it will choose the supplier with the lower unit cost. So it's Jones with only 139.60, but that of Claro is 141.20. So in this connection, Ventana may purchase all from Jones, no? From Jones, uh, even with 45,000 windshields, that is now the total of 15,000 and 30,000. So it can buy all of this from Jones, though there are problems that it may encounter in connection with. Another possibility is to not shift to window shield business to Jones unless they are willing to sell more side windows. Okay, so we have now problem uh, 7-3, activity-based customer costing. 7-2 is activity-based supplier costing. This one is customer costing. Now, we are now required to calculate the unit bid price offered to these customers, assuming that order filling cost is allocated to each customer category in proportion to units sold. So we have now this company sells custom-made machine parts to industrial equipment manufacturers by bidding cost plus 40%. So by bidding, cost plus 40%, where cost is defined as manufacturing cost plus order processing cost. So manufacturing cost plus order processing cost. There are two types of customers: those who place small frequent orders and those who place larger, less frequent orders. Cost and sales information by customer categories provided below. So we have now the frequently ordering customers and the less frequently ordering customers. We have now the sales orders, the order size, the average unit manufacturing cost, and the order processing activity cost. So we have now the order filling capacity is purchased in steps, order processing clerks of 1,000, each step costing $40,000. Variable order filling activity costs are $30 per order. The activity capacity is 39,000 orders. Thus, the total order filling cost is 2,715,039 steps, which is taken by dividing 39,000 by 1,000, and each step costs 40,000 plus 30, that's per order, times 38,500, which is the total of 35,000 and 3,000 500. Current practice allocates ordering cost in proportion to the units purchased. This recently lost a bid for 100 units. The per unit bid price was 2 per unit, $2 per unit more than the winning bid. The manager of bids was worried that this was a recurring trend for the larger orders. Other large orders had been lost with similar margins of loss. No such problem was taking place for the smaller orders. The company rarely lost bids on smaller orders required. Calculate the unit bid price offered to these customers, assuming that order filling cost is allocated to each customer category in proportion to units sold. 2. Assume that the newly implemented ABC system concludes that the number of orders placed is the best cost driver for the order filling activity. Assign order filling cost using this driver to each customer type and then calculate the new unit bid price for each customer type. Using this new price, would Deeds have won the bid for the 100 units recently lost? Okay, so first we have to determine the ordering cost allocation for each customer category. So actually the total ordering cost is 2,715,000, and you multiply this by 350,000 over 700,000. The 350,000, that's the result of multiplying sales orders 35,000 times 10 for the frequently ordering customers, and another 350 or 100 orders times 3,500 for the less frequently ordering. So all in all, you get 350,000 plus 350,000, a total of 700,000 for the total units sold. So 350 for the each customer category, 350,000 over the total of 700,000. Then we multiply this by 2,715,000. This is now your total cost. So we have to allocate 1,357,500 to each category. So for the bid price, either customer category, you have now 50. That's the average unit manufacturing cost. So we have 50 for the average unit manufacturing cost. It's 50, and we add 1,357,500 divided by 350,000 orders, no? Or we have now the number of units, and we multiply it by 1.4. Actually, hambalya, ang bid price is equal to cost plus 40%. That's why you get 1.4. So what you will do is you add 50 to the quotient in dividing 1,357,500 by 350,000, and based on the total you multiply by 1.4. So you get now the bid price of 75.43. Now for number 2, assume that we have the ABC system. They frequently ordering 35,000 sales orders. We divide by 38,500. That's the total number of orders. And you multiply by 2,715,000, the total order filling cost. So we now get 2,468,182 and the less frequently ordering is 3,500 divided by 38,500 times 2,715,000. So you have now the order cost allocation leading to the bid price. For the frequently ordering, we have now the bid price taken by adding 50, 50, and then we are going to add the quotient in dividing 2468,182 by 350,000, and you multiply it by 1.4, so you get 79.87. That's for the frequently ordering. However, for the less frequently ordering, you have 70.99, rounded to the nearest cent. Deeds could easily have won the bid for the 100 units as the price is more than $4 lower than the original bid price Now, in number 3, we have the orders for 35 units. We have now 350,000 divided by 35. So you get 10,000. That's your frequent order category. That's in requirement number 3. So in requirement number 3. Okay, what if bids offers a discount for order of 35 units or more to the frequently ordering customers? Assume that all frequently ordering customers can and do take advantage of this offer at the minimum level possible. So, at the minimum level possible. Candidates offer the original price from requirement 1 to the frequently ordering customers and not decrease its profitability. So in requirement number 3, we have the orders for 35 units. So we have 350,000 units, and we have now divide 350,000 by 35. So you have now your frequent order category taken. 350,000 is 35,000 times 10. So 350,000 divided by 35. That gives us 10,000 for the frequent orders. And the total orders, 10,000 plus 3,500 for the less frequently ordering. So you have 13,500. The capacity, number of clerks or staffs, 13,500 divided by 1,000. So we have 13.5, or rounded to, that will be 14 steps. So for the order filling cost, 14 times 40,000 plus 30 times 13,500 equals 965,000. So 9 order filling costs assigned to frequent category, 10,000 divided by 13,500 times 965,000, or 714,815. So the bid price is 50 plus the quotient, and you multiply by 1.4, and you get 72.86. Yes, the new bid price based on quantity discounting incentives is lower than the original bid price, and so the original bid price could be offered without decreasing profits under the new structure. Okay, that's problem 7-3. Now we go to another problem, 7-4. 7-4, we have activity-based life cycle costing. Kaigo design engineers are in the process of developing a new green product, one that will significantly reduce impact on environment and yet still provide the desired customer functionality. Okay, so we have now currently two designs are being considered. The manager of Kaggle had told the engineers that the cost for the new product cannot exceed $550 per unit. That's the target cost. In the past, the cost accounting department has given estimated cost using a unit-based system. At the request of the engineering department, cost accounting is providing both unit and activity-based accounting information made possible by a recent pilot study producing the activity-based data. So you have now the unit-based system, the variable conversion activity rate, $100 per direct labor hour. Material usage rate is $20 per part. The ABC system, the labor usage is $15 per direct labor hour. Material usage, direct materials, $20 per part. The machining, 75 per machine hour. Purchasing activity, 150 per purchase order. Setup activity, 3,000 per setup hour. Warranty activity, $500 per return unit. Usually requires extensive rework. Customer repair cost, $25 per repair hour average. Activity and resource information, the annual estimates, units produced for designs A and B, direct material usage, labor usage, machine hours, purchase orders, setup hours, returned units, and repair time. Customer are required, select the lower cost design unit using unit-based costing. Are logistical and post-purchase activities considered in this analysis? So we have now in problem 11-4 or 7-4, for if we use number 1, unit-based costing. So unit-based costing for direct materials, we have 6,000 computed by multiplying 20 by 300,000, and 5.5 million computed by multiplying 20 by 275,000. Conversion cost is taken by multiplying 100 by 50,000 and 100 by 120,000. That's why you have 12 million. So the total manufacturing cost for designs A and B, and now we divide it by the units produced. Now we have the unit cost for design A is only 440, but for design B it's $700. Door, ga connecting ga aw. Okay, so for requirement 2, we are going to use activity-based costing. So for direct materials, we have the same amounts. For direct labor, we are now multiplying the number of labor here, direct labor. So what do we multiply in computing for? Yan. Okay, so we have now your direct labor taken by multiplying 15,000. That's your direct labor cost multiplied by the number of labor hours of 50,000 for design A and 120,000 hours for design B. Now for machining, in machining, we are now multiplying the number of machine hours by the machining rate. So 75 times 50,000 and 75 times 60,000. So we have now the machining rate. Then for purchasing, we are going to use still letter A multiplying 150 150 times 2,000. Okay, so that's now 450 per purchase order multiplied by the number of purchase orders, and then multiply 150 by 1,500 number of orders. Then for per setups, we now multiply in setups 3,000 times 600 and 3,000 times 200. And then for the warranty, we have 500 times 1,000 and 500 times 250. Now we get the total product cost, and we have to divide this with the number of units produced, and we get the unit cost.